Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya Sagar. Today, I will deliver my lecture, my talk on silicate minerals, and in this topic, I will cover about the silicate minerals and mainly nesosilicate minerals, olivine, garnet, aluminosilicate groups, stolite, zircon, topaz and spin. The identification of minerals is based on physical properties such as crystal system, forms, color, lustre, hardness and cleavage, etc. The basic structure unit of all silicate minerals is the silicon tetrahedron, in which one silicon atom is surrounded by 4 oxygen atoms, each at the corner of a regular tetrahedron. These SiO4 tetrahedral units can share oxygen atoms and be linked in a variety of ways, which results in the different structures. For example, nesosilicates are minerals whose structures are made up of independent silicate tetrahedrons. Sorosilicates are the silicate minerals consisting of double tetrahedral groups in which one oxygen atom is shared by 2 tetrahedrons. Cyclosilicates, in contrast, are arranged in ring made up of 3, 4 or 6 tetrahedral units. Inosilicates show a single chain structures where in each tetrahedron share 2 oxygen atoms. Phyllosilicates have a sheet structures in which each tetrahedron share 1 oxygen atoms with each other of 3 other tetrahedrons. Tectosilicates show a 3-dimensional network of tetrahedron with each tetrahedral unit sharing all of the oxygen atoms. The learning process for the identifying minerals is based on physical properties such as lustre, hardness, cleavage, etc. For identification of minerals in lab, the students required a hand lens, a glass pieces, a copper coin, a pocket knife, a common magnet and dilute HCl. The following description is given for common silicate minerals for identification of minerals. Olivine, Fe Mg2SiO4. Physical properties: crystal system, orthorhombic, form commonly granular, color olive green, olivine, white color phosphorite, black color black or brown color phyllite. Strict, usually colorless. Lustre is vitreous, fracture conchoidal. Hardness 6 to 7. Specific gravity is 3.2. Phosphorite 4.3, phyllite 3.3 to 3.4 for common olivine. Variety: peridot is a gem variety of olivine, transparent and pale green. Distinguished features: distinguished feature of its vitreous lustre, conchoidal fractures, green color and granular forms. Alteration: readily altered to serpentine, Mg6 Si4O10 OH8 and magnesite MgCO3. Occurrences: olivine is typically a minerals of ultra basic rocks, for example petrotite and dunite, made up of almost wholly of olivine. Second, in basic rocks it occurs in gabbros, dolerite or basalt. Olivine does not occur in the presence of quartz. If quartz is present, it would form orthopyroxene. The reaction is MgFe twice SiO4 plus SiO2 give rise to MgFe twice Si2O6. Fayalite occur in acid igneous rocks. Phosphorite is formed by the metamorphism of dolomite limestone. Uses: owing to very high melting point, which for fayalite is 1205 degrees centigrade and for the phosphorite 1892 degrees centigrade. Magnesium rich olivine is used in the manufacture of refractory. The transparent green variety of olivine peridot found in Myanmar. Indian occurrences: Mysore district of Karnataka, Salem in Tamil Nadu, Chaibasa in Singhbhum. Now next nesosilicate mineral is garnet. The general formula is X3Y2Z3O12. Varieties: almandine, Fe3, Al2, Si3O12, pyrope, Mg3, Al2, Si3O12, serpentine, Mn3, Al2, Si3O12, granular, Ca3, Al2, Si3O12, andradite, Ca3, Fe twice, Si3O12. Urbovite is Ca3, Cr2, Si3O12. Composition: the composition of naturally occurring garnet approaches the formula given above due to extensive atomic substitution. The specific names applied is that of the component present in large amount. Ferrous, iron and magnesium are interchangeable, and a series of intermediate composition are known between almandine and serpentine and between gracilorite and andradite. The difference in ionic size between calcium on one hand and Fe+2 and Mg on the other result in limited substitution, and a wide composition gap exists between gracilorite, andradite on one hand and almandine, pyrope and spessartine on the other. Physical properties: crystal system, isometric, cubic, form crystal commons, usually dodecahedral and also massive. Color: variable, dark red or reddish brown common, but urovite is green color. Streak: white or play sets of body color. Cleavage: absent. Fracture: subconchoidal or uneven. Hardness varies from 6.5 to 7.5. Specific gravity varies from 3.5 to 4.3. Depending upon composition: almandine 4.3, spessartine 4.19, gracilorite 3.69, pyrope 3.58, andradite 3.86 and urovite 3.78. Distinguished features: isometric crystal form, hardness and color taken together serve to distinguish members of the garnet groups. Occurrences: almandine common in metamorphic rocks, schist and gneisses. Pyrope occur in eclogites, ultrabasic rocks and kimberlites. Spessartine occur in metamorphosed amine-bearing rocks or low-grade metamorphic schist. Granular: contact or regional metamorphism of impure limestone. Andradite: it is formed by the metasomatic alteration of limestone by iron-bearing solution CaCO3 plus Fe2O3 plus SiO2 give rise to Ca3 Fe2 Si3O12 plus 3 CO2. Urovite: it's emerald green and it is rarest of 6 garnet and occur mainly in serpentinites. Uses: as an abrasive. Transparent variety is used as gemstone. Aluminosilicate groups. Varieties: the group includes 3 important polymorphs of Al2 SiO5, that is kyanite, sillimanite and andalusite. Composition: the crystal structures of all the 3 minerals are closely related and contain independent SiO4 tetrahedron and chain of octahedral of alumina parallel to C-axis. Presence of these chain is responsible for elongation of crystal on these minerals along C-axis. The phase relation of these minerals has been studied by various workers. Experiments by Richardson, Gilbert and Wells in 1969 located the triple point at 622 degrees centigrade at 5.5 kilobar. The experimental work investigation of the aluminosilicate stability by Holdway 1971 is accepted universally, that is at 501 degrees centigrade at 3.79 kilobar. Andalusite is formed at moderate temperature and low pressure, so that it is typical of thermal metamorphosed argillaceous rocks and low pressure regional metamorphism. Sillimanite is formed at high temperature, so that it is found in rocks of the innermost zone of thermal metamorphism or in regional metamorphic rocks of higher grade. Kyanite is the form is stable under high pressure, intermediate temperature, so that it characterizes regional metamorphism rocks of the intermediate grade and usually absent in thermal metamorphism because not stable below 4 kilobars. One heating of more than 1200 degrees centigrade temperature, aluminosilicate change into mullite, Al2Si2O12, Al2O3, 2SiO2 and silica rich glass, which is used as refractory bricks. 3Al2O3 SiO2 give rise to 3Al2O3 2SiO2 plus SiO2, that is aluminosilicate give rise to mullite plus glass. Kyanite Al2SiO5 physical properties, crystal system, triclinic, forms bladed or sometimes acicular radiating. Color sky blue or darker sets of blue towards the center with white marginal portion. Streak white, lustre pearly on cleavage surface. Cleavage perfect. Hardness varies on different faces 4 to 7. Specific gravity 3.6 to 3.7. Distinguished features: bladed form, bluish color, good cleavage and variable hardness in different direction. Uses as a refractory minerals. Occurrences: kyanite is product of medium grade regional metamorphism of aluminous rich rocks, that is kyanites, etc. Indian occurrences: Bhandara district of Maharashtra, Singhbhum kyanite deposit, etc. Sillimanite Al2SiO5 physical properties, crystal system orthorhombic, forms acicular or fibrous, color white, sometimes greenish or brown, streak white, lustre vitreous or silky, cleavage one set but not clear in hand specimens. Hardness 6.7, specific gravity 3.2. Distinguishing features: slender crystals form and one directional cleavage characteristic of these minerals. Uses as a refractory minerals. Occurrences: sillimanite is formed in aluminum rich rocks under condition of high grade regional metamorphism, sillimanite niches, etc. Indian occurrences: the largest and richest known sillimanite deposit occurs at Sonapahar, Khasi Hills, Meghalaya, Piparia in Rewa district of MP and Karnataka. Andalusite Al2SiO5 physical property, crystal system orthorhombic, form coarse prismatic crystals with nearly square cross sections, color white or brown, streak white, lustre vitreous, cleavage one set, fracture uneven, Hardness varies on different phases 7 to 7.5. Specific gravity 3.2. Distinguishing features: prismatic crystals with a square cross section from bluish color, good cleavage, and variable hardness in different directions. Variety: chrysolites has a dark colored carbonaceous inclusion arranged in a regular manner, forming a cruciform. Uses: in manufacture of spark plugs. Occurrences especially in Spain, Austria, etc. Staurolite: FeAl4, Si2, O10, OH twice. Physical property: crystal system orthorhombic, forms crystal common with obtuse prism, unlike andalusite, which is characterized by square prism. Cruciform twins. Color: reddish brown to brownish black. Streak: colorless or grayish. Lustre: vitreous. Cleavage: present one set. Hardness: conchoidal. Specific gravity 3.7. Distinguishing features: crystal with cruciform twin. Occurrences: staurolites occur in medium grade regional metamorphism rocks and is found in aluminum rich schist zircon ZrSiO4. Thorium and uranium replace Zr and thus it is radioactive. Physical property: crystal system tetragonal, form prismatic tetragonal prism. Color: reddish brown. Streak: colorless. Lustre: adamantine. Cleavage: indistinct. Fractures: conchoidal. Hardness: 7.5. Specific gravity 4.7. Distinguishing features: characteristic crystals, color, lustre, and hardness are important diagnostic features. Occurrences: as an accessory minerals in igneous rocks, for example granite and pegmatites. In metamorphic rocks, as detrital minerals in beach sands in India, Sri Lanka, Australia, etc. Uses: source of zirconium, which is used in the construction of nuclear reactor. Alloy and chemicals: transparent zircons are gemstones resembling diamond. Indian occurrences: monazite belt which extends from Kulon to beach, Bhandara district, Maharashtra. Topaz. Al2 SiO4, fluorine OH twice. Physical properties: crystal system orthorhombic, forms prismatic, massive or granular. Color: wine yellow. Streak: colorless. Lustre: vitreous. Cleavage: uneven. Hardness: 8. Specific gravity 3.5 to 3.6. Distinguishing features: recognized by its basal cleavage, hardness, and high specific gravity. Occurrences: an acid igneous rocks, for example granite or rhyolite. In pegmatites, uses: transparent. Variety is used as a gemstone. Indian occurrences: Sirohi district of Rajasthan, Kodarma mica belts Bihar, Bhandara district of Maharashtra. Sphene titanite, CaTiOSiO4. Physical properties: crystal system monoclinic, forms wedge-shaped crystals. Color: yellow, gray, brown. Streak: colorless. Lustre: highly vitreous. Cleavage: parallel to 1 knot. Fracture: conchoidal. Hardness: 5 to 5.5. Specific gravity 3.4 to 3.5. Distinguishing features: recognized by wedge-shaped form. Occurrences: common accessory minerals in granitic rocks, also found in gneisses and amphibolites. Source of titanium. Uses: titanium oxide used as a paint and pigments. Indian occurrences: greenstone belts of Dharwar Craton, other cratonic area of Indian shields. Today in silicate minerals topic, I have covered the general classification of silicate minerals and mainly nesosilicate minerals, in which I have covered olivine, garnet, aluminosilicate groups, sterlite, zircon, topaz and sphene minerals, which all comes under the category of nesosilicate. The identification of minerals is based on physical properties such as crystal system, forms, color, luster, hardness and cleavage, etc. For the further studies, please read the textbooks and references given in the text. In my next lecture, Silicate Minerals 2, I will cover the sorosilicate and cyclosilicate minerals. Thank you very much.